Hey everyone, and welcome to our deep dive today. It's gonna
Yeah,
be a really cool one.
it is.
Um, we're talking about the future of electronics,
That's right.
but specifically like how chemistry is driving these innovations.
Yeah.
So if you went for this awesome source called Cocktail Party Chemistry,
Oh, yeah.
episode 18,
Mm-hmm.
and it's called Emerging Electronic Materials and Displays.
Catchy title.
I know, right? And they lay out these 5 really cool, like, factoids that we're going to kind of dig into today.
Yeah, they're like little glimpses into the future.
To-
Not even the future. Like,
Yeah.
what's happening right now?
Yeah, it's like sci-fi stuff, but it's real.
Yeah.
Okay, so first up, let's talk OLEDs.
Okay.
So I feel like we've all seen these like crazy vibrant screens
Right.
like on, fancy TVs and smartphones.
Yeah.
But what makes them so different from a regular LCD screen?
So with an LCD screen, you have backlight.
Okay.
So it's kind of like shining a flashlight through a sheet of paper.
Right.
But with an OLED, each pixel is actually emitting its own light.
Wait, so each tiny dot on the screen
Yes.
is like its own little light bulb.
Kinda.
Wow, that's wild.
Yeah, it is.
So what does that mean for the picture quality?
Oh, it's huge.
Yeah.
You get perfect blacks because when a pixel is off, it's off.
Oh.
There's no light at all.
Interesting.
You get incredible contrast.
Okay.
Super fast response times, perfect for gamers.
Oh, yeah.
People who love action movies.
So it's like way more immersive.
Yeah.
Okay, so that's cool.
Yeah.
But I've also heard about these like flexible OLED displays.
Yes.
Is that actually a thing?
Absolutely.
What?
Yeah.
How does that even work?
So you can actually print these OLEDs onto flexible surfaces.
Okay.
So imagine a phone that folds in half.
Oh my God.
Or a TV that rolls up like a scroll.
That's insane.
Yeah.
That's straight out of the future.
I know.
All right. So next up we have electrochromic materials,
Okay.
which also sounds like something out of a superhero movie.
Yeah.
What are these color-changing wonders all about?
Okay, so imagine a window that tints itself automatically.
Yeah.
When it's sunny out.
Wait, hold on.
Mm-hmm.
You're telling me we could have windows that change color
Yeah.
on command?
Basically. How does that even work?
So these materials change their structure
Okay.
when you apply a small electrical voltage.
Okay.
And that changes how they absorb and reflect light.
So it's not like they're painted with different colors.
Yeah.
It's the actual material itself transforming.
Yeah.
That's crazy. I can see this being used in all sorts of cool ways.
Oh, for sure.
Like beyond just windows.
Yeah, like dynamic camouflage.
Yeah.
Even clothes that change color.
That's awesome.
Yeah.
Okay, moving on to something a little more complex.
What's that?
Spintronics.
Now, this one gets a little deep into
Oh.
quantum physics.
Oh.
But basically, instead of using the charge of electrons,
Okay.
like in traditional electronics,
Mm-hmm.
spintronics uses the spin of an electron.
Okay. So it's not just about the electron moving.
It's how it's spinning
Exactly.
as it moves.
Yeah. And that spin can be like a 1 or a 0
Okay.
for data.
So is this going to make my computer run faster?
Think way beyond that.
Okay.
Like devices that are thousands of times faster
Wow.
with way more storage capacity,
Okay.
and they use less energy.
Now that is mind-blowing.
Yeah.
All right, next we've got holographic data storage.
All right.
I know we're generating more data than ever before,
We are.
and those little thumb drives just aren't cutting it anymore.
Yeah. Traditional storage is hitting its limits.
So what's the solution?
Holographic data storage.
Okay.
Instead of storing data on a flat surface,
Right.
it uses lasers to store information in 3 dimensions.
Wait, so we're talking about storing data
Yes.
in 3D space.
Yeah, think of it like a crystal
Okay.
or a polymer.
So how much data can you actually get into one of these things?
So a single device, the size of a sugar cube,
Okay.
could hold terabytes of information.
That's like an entire library
Yeah.
in my pocket.
Pretty much.
That is just bananas.
Huh.
And is this like actually happening?
Yeah, researchers are making incredible strides.
Wow.
Like companies are already building prototypes.
Really?
Yeah, and some experts think it could be commercially available
Wow.
within the next decade.
Okay, last but not least, we have molecular machines.
Okay.
This sounds like the most futuristic concept of them all.
It's pretty wild.
So are we talking about like tiny robots?
Not quite robots.
Okay.
But imagine a machine so small
Okay.
that it operates at the level of molecules.
So like how small are we talking?
We're talking about synthetic molecules.
Yeah.
Designed to perform specific tasks,
Okay.
triggered by things like light or heat.
So can you give me like a real world example?
Yeah, picture this.
Okay.
Tiny machines delivering medicine directly to diseased cells
Oh, wow.
in your body.
So we're talking about a level of precision that's just unimaginable
Yeah.
with current technology.
Pretty much.
This is some serious science fiction stuff. But you're telling me this is happening right now.
It's happening, and the potential is huge.
Like, what else could they do?
Think about microscopic sensors.
Okay.
Monitoring the environment for pollutants.
So we're talking about transforming.
Yeah.
Like everything from medicine to manufacturing.
Absolutely.
I am officially blown away.
Me too.
We've only scratched the surface
Yeah.
of these 5 incredible technologies.
Yeah. But it's clear they have the potential to change the world.
Totally. And the best part is,
Yeah.
this is just the beginning.
It is.
As scientists continue to explore chemistry at the nanoscale.
Who knows what other breakthroughs are waiting to be discovered?
Right? Well, there you have it.
Yeah.
A glimpse into the future of electronics.
The future is now.
I know, it's pretty amazing.
It is.
And we'll be back in part 2
Okay.
to delve a little deeper into some of the specific challenges and opportunities
That's good.
that these technologies present. So stay tuned.
All right. Welcome back to our deep dive.
Back into the future of electronics. That's right.
It's like, I'm still trying to process everything we talked about in part 1.
Yeah, there's a lot to unpack.
I know it's exciting, but also kind of intimidating.
Yeah,
To think about, like, how much work still needs to be done,
it's true.
to actually make these innovations a reality.
Yeah, and sometimes the challenges are even bigger than you might expect.
Right. It's like it's easy to get caught up in that, like, wow factor.
Right.
But then you realize, like, oh, there's a lot of chemistry problems to solve
Yes.
before we can have, like, self-tinting windows and molecular machines running around.
It's not all magic.
Yeah, it's like we're manipulating matter at, like, the atomic level. That
Yeah.
can't be easy.
It's not.
So, like, where do those challenges come in?
We'll take OLEDs, for example.
Okay.
One of the biggest hurdles has been stability.
Oh, really?
Yeah, organic molecules are really sensitive,
Okay.
like heat and light and moisture.
So, like, more so than inorganic materials.
Yeah, they tend to break down faster. That makes sense.
Yeah.
So how are scientists tackling that problem?
They're developing new organic compounds that are tougher
Oh, okay.
and more resistant to degradation.
And are they like finding ways to protect those molecules too?
Yeah, they're experimenting with encapsulation techniques.
So it's like you're trying to like shield them from the elements.
Exact.
Okay, and how's that going?
It's a race, but we're making progress.
That's good.
OLED displays are starting to rival LCDs in terms of lifespan.
That's awesome.
Yeah.
So maybe those foldable phones aren't that far off.
Fingers crossed.
I know, I'm excited about those.
Me too.
But it's not just about durability, right?
No, there are performance challenges too.
Especially when you're talking about like displays that change color
Yeah, or transparent.
on demand.
Right, like electrochromic windows need to switch between states quickly
Okay.
and smoothly.
And they need to block a wide range of wavelengths.
Yeah, it's not just about finding a material that changes color.
Right.
It's about fine-tuning its properties.
So it's like finding the perfect recipe
Kind of.
to achieve that desired outcome.
Exactly.
Okay, well, speaking of recipes, let's talk about spintronics.
Okay.
You mentioned this field is still kind of in its early stages.
Yeah, it's really days.
So what are some of the biggest obstacles they're facing?
I think controlling electron spin at really small scales is a major challenge.
Yeah, I can imagine like we're talking about tiny magnets here.
Yeah, and trying to align them.
Yeah.
It's like herding cats.
Yeah, at the atomic level.
Exactly.
So it's not just about understanding the theory.
Right.
It's about actually putting it into practice.
Yeah, you need the tools and techniques.
And this is where like collaboration between different fields becomes really important.
Oh, absolutely.
Right? You need physicists, chemists, engineers
Yeah, all working together.
to make it happen.
Hmm.
But if they can pull it off,
The rewards are huge.
yeah, we're talking about a potential revolution in computing.
Faster speeds, lower energy consumption.
That's amazing. Okay, but let's shift gears a little bit.
Okay.
Back to holographic data storage.
Mm-hmm.
We talked about this mind-boggling storage capacity.
Yeah, terabytes in a sugar cube.
Right. But I imagine there's some serious hurdles to overcome
Oh, yeah, there are.
before we can all have libraries in our pockets.
Like what?
Like, what are those hurdles?
Well, developing materials that can store and retrieve information reliably
Go ahead.
without any data loss.
Right, because it's not just about storing the data.
No.
You have to be able to access it again.
Exactly.
And you need it.
And then there's scalability.
Okay.
Making it work on a large scale.
And affordable.
Right. It can't cost a fortune.
Okay, so those are some pretty big challenges.
They are.
Okay, well, let's move on to our final frontier,
Okay.
molecular machines.
All right.
We talked about how mind-bogglingly small these things are.
Yeah.
So I imagine building and controlling them
Yeah.
must be a nightmare.
It's pretty challenging.
Like, what are some of the specific headaches
synthesizing the molecules themselves
Okay.
with the right structures and functions.
So, like, how do you even do that?
It requires a deep understanding of chemistry,
Okay.
like bonding and molecular geometry.
So it's like building a house of cards,
Yeah,
but on a molecular scale.
pretty much.
That's intense. And then once you've actually built these tiny machines,
Yeah,
how do you control them?
that's the other big challenge.
Yeah, you can't exactly like grab them with tweezers and be like,
Right.
go do this.
Scientists are exploring different approaches,
Okay.
like using light or chemical signals
Okay.
as triggers.
So we're basically trying to mimic
Yeah.
the machinery of life itself.
In a way.
It's pretty incredible.
It is, and the potential is huge.
It's almost endless.
Yeah.
But I imagine there are ethical considerations too.
Oh, definitely.
Right? Like we're talking about really powerful technology.
Yeah, we need to be responsible.
And make sure it's used for good.
Absolutely.
Well, we've explored the incredible potential of these technologies. And we've acknowledged some of the challenges
Yeah.
that lie ahead.
So what's next?
All right, welcome back for the final part of our deep dive.
Yeah, it's been quite a journey, hasn't it?
It really has, like from those color-changing windows to those molecular machines.
Yeah, we've covered some pretty mind-bending stuff.
I know, it feels like we took a crash course in science fiction.
Yeah.
But the amazing thing is, like, this is all based on real science.
Yeah.
It's happening right now.
In labs all around the world.
So let's talk about, like, what's next.
Okay.
Like, where do we go from here?
Well, I think one area to watch is, like, pushing the boundaries
Okay.
of existing materials.
Okay.
So, like, with OLEDs,
Okay.
we've made huge progress with stability
Mhm.
and efficiency,
Right.
but we can still improve things like brightness
Okay.
and color gamut.
So how are they going to do that?
Well, scientists are exploring new types of organic molecules,
Okay.
like phosphorescent emitters
Okay.
and TADF emitters. It stands for thermally activated delayed fluorescence.
Okay, what do those do?
Basically, they could make OLEDs way more efficient
Okay.
and give them a wider range of colors.
So we could see even more vibrant images.
Yeah, and more realistic colors.
Oh, that's cool.
Plus, better efficiency means longer battery life.
Right. Which is always a plus.
Always.
What about electrochromic materials?
So with those, I think we're going to see them go beyond just changing color.
Okay.
Like imagine controlling transparency,
Okay.
reflectivity,
Yeah.
even conductivity.
Oh, with like a switch.
Yeah, imagine windows that can generate solar power.
Oh, wow.
Or camouflage that adapts to any environment.
That's amazing.
Or flexible circuits that can be molded into any shape.
So we're talking about like materials that can interact
Yeah.
with their surroundings.
Yeah, responsive materials.
Okay, that's really cool. What about spintronics?
So with spintronics, the challenge is still controlling that spin
Right.
at tiny scales. But researchers are exploring some interesting materials,
Okay.
like topological insulators.
What are those?
They conduct electricity only on their surface,
Okay.
and the electron spin is linked to their direction.
So it's like creating a highway
Yeah.
for electrons.
Yeah, with specific spin states.
And that could lead to more efficient spintronic devices.
Way more efficient.
Okay, what about holographic data storage?
So with that one, it's all about scaling up.
Right, making it affordable.
Exactly. But there's some cool research happening.
Oh, yeah? Like what?
With photorefractive polymers.
Okay.
These could be molded into large-scale storage media.
So instead of those tiny sugar cubes,
Yeah.
we could have like credit card-sized devices.
Or even bigger.
And how much data could they hold?
Potentially terabytes. Wow. Maybe even more.
Okay, last but not least,
Yeah.
those molecular machines.
Right.
We talked about the challenges of building and controlling them.
Yeah, those are big challenges.
So are there any like breakthroughs on the horizon?
I think DNA nanotechnology is super promising.
Okay.
Scientists are using DNA to build self-assembling machines.
Wait, so like tiny robots made of DNA?
Pretty much.
And what could they do?
Think about delivering drugs with pinpoint accuracy
Okay.
or repairing damaged cells.
It's like harnessing the power of biology.
Yeah, to build incredibly complex machines.
Wow, that's really amazing.
And there's also artificial photosynthesis.
Right, trying to mimic plants.
Exactly. If we can figure that out,
Yeah.
we can have molecular machines that create their own fuel.
Okay, so like sustainable energy.
Exactly.
That's pretty incredible to think about.
It really is.
Like the scale of innovation happening in this field.
Yeah, from displays to tiny machines.
It's just like there's no limit.
No limit. But one thing's for sure,
What's that?
chemistry is at the heart of it all.
Totally. So to all the budding scientists out there,
Yeah.
if you're looking for a field with endless possibilities.
Chemistry is the one.
It's a field where you can truly make a difference.
Shape the future of technology.
And create a better world.
For everyone.
Well, that wraps up our deep dive into the future of electronics.
I hope you enjoyed it.
Thanks for joining us.
Yeah. Thanks for listening, everyone.